All right. So I won't deny that it is not challenging, but remember, if you put your efforts, there is some memorization. If you do that, if you spend more time to learn, understand the material, chemistry is not that hard. All right. So you may have different experience based on your school, or you may take chemistry like really long time back. That could be a different story. But keep in mind, chemistry is challenging if you put your effort, if you keep your focus on, if you try to learn, if you contact, like any help you get, like maybe tutor, or you can contact me or your lecture instructor, you can definitely get a good grades. All right. So first thing you gotta keep in mind is chemistry is challenging, but not hard. All right. So let's start with that. All right. So I hope all of you guys have the lab handout that, like, sorry, the handout that I sent you yesterday. So if you have a printout copy, it's nice. If you do not have it, you can just leave it open on your second tab in the computer. I'm going to share the same information in the form of PowerPoint slide. So we are going to talk about that. Let me just give me 1 minute. All right. So I'm going to share my screen. All right. So I'm going to erase this. All right. Let's see, erase. Okay. So I'm going to take, I do need to write on the screen. So I'm going to turn off my camera. Otherwise my face is going to look like a horrible. So I'm going to stop my camera and we are going to discuss the material. So again, welcome everybody to pre-chemistry workshop. The intention of mine to have this workshop is to help you guys do well in the coming chemistry class that you're going to take. So what we get to learn today, we are going to talk about the basic math problems. All right, before we start, let me just ask that. Can you guys see the screen, right? Everybody can see the screen?
Yes.
Yeah.
Yeah, we can see.
Professor.
Okay, wonderful, wonderful, great. All right, so today what we're going to learn, we are going to talk about the basic math skill that you need to have. I know some students are taking this chemistry class after a really long time, and I just need to make sure that you kind of, refresh your memory, how to do the basic math. Once we know that, we're going to talk about the different measurement you are going to learn in the course. This is like the first and the second chapter, depending on which course you are taking, and the units. So what are the units of this different measurement and the prefixes? So prefix is something we're going to talk in detail, and there are some memorization for prefix. I will definitely try my best to help you remember. After that, we are going to talk about significant figures. This is really important point. Definitely going to be 2.2, maybe like 4-point question in any course you are taking as a multiple choice question. All right, definitely very, very important. So please stay focused. And the formulas, there are a few formulas that you need to remember. So we just going to talk about a couple of formulas and we are going to solve the problem using this. All right. So let's move on. Do you guys have any question for me before we start?
No.
Everybody's good? All right. Okay, so first of all, what we're going to do, we are going to learn how to convert decimal notation into scientific notation. So let's see how many of you remember this. All right, so do you know the decimal notation? It is right here, right? You have this number, which is in a decimal notation. It means it has a decimal point in it. If I'm asking you to convert that into scientific notation, anybody has any idea how you're going to do it?
Um, I'm pretty sure you move the decimal place over to the left until it's between only one digit, and until there's only one decimal after the digit, and then you write times 10 to the, however many, to whatever number you moved it over, you
All
write
right,
that as the exponent, something like that.
Uh,
that's
like we
right.
can write it as 31,254 into 10 inverse 2.
Okay, that's right. So let's see, right? Let's just learn one more time here how we supposed to write it. So first thing you got to remember for scientific notation is in the scientific notation, you have to move your decimal place after the first non-zero number, decimal, let's say decimal point after your first non-zero zero digit. All right, so which is your first non-zero digit in this number? 3. Number 3 is your first non-zero. Non-zero means something other than 0, right? So you have to move your decimal place after 3. So 3 point something. So if you just want to write scientific notation, it is going to be 3.1254. Scientific notation, what is going to have is going to have multiplication of 10, and there must be something to the power. All right, so first point, you have to remember decimal point after the first non-zero number, and then you have multiplication of 10 to the power of something, right? When I draw the box, it means there must be something. What that power is going to be. So in this example, because you are moving on the left side, that's one way to learn, right? 10 to the power is going to be, you move how many places? You move your decimal place 1 and 2 places. It means it's going to be plus 2. If you move your decimal place on the left side 2 places, it's going to be plus 2. All right, this is the one way to understand. The way I want you to understand is this. Let's say if I have given you this number, and if you have to convert that into the scientific notation, first of all, you must remember the rule. Scientific notation, it has to be 3.1254, and there must be 10 to multiplications. All right, this is something you know. Now you have to compare this number. You have to compare the number that you came up with and the number which was given to you. By comparing these two numbers, if I'm going to ask you, how does this number look in compared to this? Does it look smaller or larger? The number which we just came up with, do you think it's small number or larger number than this number? The
Small number.
By itself, smaller.
It's small.
small, everybody agree, right? Why? Because this is 312 point something. The number we came up with is 3.2 something. So of course 3 is less than 300. If this number is smaller, it means you have to have plus sign, 10 to the something, which is going to be plus sign. In here you move your decimal place 2 point, right? 2 places, so it should be plus 2, or simply you can just say 2. All right, do you understand this?
Yes.
Yeah, I do.
Confused.
All right. The question?
Yeah, I feel a little confused.
All right, so the point of writing decimal notation and scientific notation is not to change the value. If the value is 312, the value has to stay same, 312. But what you can do, you can just write down in scientific notation, which could be, of course, 3.1254. When you write this fashion, right, in this fashion, what it indicates, you change the value. This is 312 and this is 3.1254, right? It is not the same value. It's not equal. To make it equal, what you have to do, you have to multiply that with 10 to the power of plus 2, which is basically 100. You get it?
Yeah, now I get it. Thank you.
All right, so keep in mind, when you change number to the smaller number, the sign has to be plus. When you change this number to the larger number, the sign on 10 to the power must be negative sign. Let's take an example, right? If you are talking about this, right, if you have to write the scientific notation, now we know the scientific notation, we have to have our decimal place after the first non-zero number, which is this 2. So the number has to be moved on 1, 2, and 3, right? So the number would be 2.54 multiplied by 10 to the power of something, right? Now let's just compare these two numbers. This number, the given number is 0.00254, and the number that we came up with is 2.54. Is this number larger or smaller than the given number?
It's larger.
Larger.
Larger, bigger, right? It
Yeah.
is a bigger number. If it's a bigger number, we have to have a negative sign because we don't want to change the value of the given number. All right. How many places did we move? 1, 2, and 3. So it should be
-3.
negative 3. Is that clear?
Yes. Yes.
Yeah.
Yes.
Everyone? Yeah.
Mm-hmm.
All right. So
Yes, Professor.
wonderful. So this is the way I want you to understand. of course, you can remember it that way, that if you move your decimal place to the left, right, it is going to be 10 to the power of plus 2. If you move it on the right, it is going to be minus something, right? This is not the right way to remember. Why? I'm going to explain you in the next slide. All right, so remember, whenever you write decimal notation or scientific notation, the purpose is not to change the value. If you come up with a number which is smaller than the actual number, you're going to have 10 to the power of plus. If you come up with a number which is larger than the given number, you're going to have 10 to the power of negative. What power? It just depends on how many decimal place did you move. All right. Moving on to the opposite function. Scientific notation has been given to you, and decimal notation is something you have to come up with. All right, so let's see how many of you can figure this out. I'm gonna give you 1 minute to try this on your own, and then we are going to discuss this. All right, so you have 1 minute. If somebody wanna understand this, take your time. You have 1 minute to figure it out, and then we are going to discuss this.
Professor?
Yes, go ahead.
The first one, 0.00786.
No,
No.
it's 7860.
Yeah, I got the same.
Yes. I'm still going to wait for like 15 more seconds to let everybody try, and then we're going to discuss this.
All right.
All right, so let's see what the number is going to be. So as you see, it is 10 to the power of 3. So at least you know that you are going to move this decimal place on like 3 places, right? Either on the left or on the right. All right, let's just see how it looks, right? Let's say if we move it like 1, 2, and 3 on the left side, so it should be 0.0786. Or if we move it on the right side, right? 1, 2, and 3, so it should be 7860. All right, so these are the two options. Everybody agree? Either you get the
I
A
do.
or you get B,
Yeah.
right? Let's see which one is going to be the right answer. Let's just compare the value, right? As I just told you earlier, the intention of this is not to change the value. If you compare this to value, right? Let me just rewrite this. 7.86 times 10 to the power of 3. Do you think these two values are same? This is 7 point something with 10 to the positive sign, and this is 0.00786. This is a smaller number, right?
Right.
If you just apply the same concept, if let's just assume this number is given to you, if you convert that to the scientific notation, what did you do? You came up with a number which is bigger than what you have here, right? If you get a bigger number, then it has to be a negative sign, which is not the case here. So of course, this is not going to be the right. Do you guys follow me?
Professor, can I say something?
Yeah, go ahead.
If I write like you write the A, we can put the into 10 power 6, right?
10 to what?
10 power 6.
Yes,
as you write on the
but
A.
that is not the decimal notation, right?
Oh, all right. Sorry.
Yeah, in the decimal notation, we have to have a decimal point like this, something like this, right? Now let's look at the second option, right? Either we came up with this, which we think it is not the right. Let's look at this number. All right, so let's just kind of go back to the previous slide and understand this. Let's just assume this number is given to us, right? 7860. And if you came up with this number 7.86, what did you do? This is a larger number, This is a smaller number. If you get a smaller number, the 10 to the multiplication has to be a positive sign. And you see that positive sign here, right? The value was +3. You guys following me?
So, Professor, do you kind of just do the opposite of what you did when changing it from decimal to scientific? Do you go the opposite direction?
Yes, that's right. All right. So if you want to say it's, or you can, what you can do, let's just rewrite the number. If you have something like this, simply what you can do, 10 to the power of 3, it means it is 1000. Just simply multiply 7.86 with 1000. All right, this is what you can do. Make sense? In which case,
Yeah.
you are going to move your decimal place to the right, 1, 2, and 3 places. So 3 right here. Do you understand?
Yes, Professor, we do.
Yes.
All right. So just keep in mind, writing in scientific notation and decimal notation, our intention is not to change the value. If you're not sure, write down both answer and compare it, right? Stick to the rule that you just learned in a previous slide. Just stick to that. It will make it easier. Again, for this one, let's try. All right. In this case, we know it's 4. So we are going to move our decimal place 4 places. Let's try both option. Option A, in which we are moving on the left side, right? So 1, 2, 3, and 4. All right. Let's see if we move decimal place like this, it should be 0.00047842. This is one possibility. The second possibility is going to be on the right side. So 1, 2, 3, and 4, right? 4, 7, 8, 4, 2, and the decimal place. All right. Now let's just compare these two number and these two value, right? And this point, what you can just do, let's just assume that this number has been given to you. If this number has been given to you, and if you convert that into scientific notation, which we just learned earlier, right? This number, how does this number look? This is larger than this number, right? So this is a larger number. If it's a larger number, right, because we do not want to change the value, the 10 to the power has to be a negative sign, which is there. All right, so it looks like that is the right answer. Again, we don't want to get to a conclusion, right? So let's just compare the another number. If we compare these two number, what do we see? In this case, again, we just have to think in the reverse fashion. Let's just assume this number has been given to you, and this is the number we just came up with. This is 47,000 something, right? This is 47,000. The number we came up with, it is 4 point something. Of course, this is a smaller number compared to number B. So it has to have 10 to the positive sign. Do we have positive sign? No, we do not. It means the answer A is right. All right, this is just one way to do it. You can definitely follow the rule that you like, but this is the way I prefer. All right, do you understand?
Yes.
Everyone?
Yeah.
Yes, Professor.
Get it.
Right.
Like,
So what I would suggest, just remember how to convert decimal to the scientific notation. Once you know that, you can just apply the opposite rule when you have to do the opposite function. All right, so you don't have to remember the different rules. All right, or when you have 10 to the power, you can just simply write it down as a 10 to the power of 3. It means you can just write down at 1000. If it's 10 to the power of 4, you can just write down 10,000 and do the multiplication. Sounds good?
yeah.
Yes,
Yes.
Professor.
Can I rephrase it just to make it clear?
Definitely.
If the number that you want to convert is bigger than the number that you are converting it to, then it should be negative. But if the number that you're converting to the another number, which is bigger than the number you're converting, is bigger than it is the positive, right?
It is a bit confusing. So what I'm going to do, I'm just going to repeat myself. All
Okay.
right. Let's see if I can. All right. Okay, let me just write it down here. All right. Let's just keep it simple. 12.12. All right. If I want to convert it into scientific notation, of course, we know I am going to write 1.212. All right. In this case, what I'm going to do, I'm going to multiply it with 10 to something. What that number should be? The given number is 12 point something. The number that we came up with, it is 1 point something. So this number, the one that we came up with, is smaller, right? This number is smaller. It cannot be smaller. It has to be the same number. If it's a smaller number, it has to have a positive sign. So it should be positive 1. Another example, 0.021, right? If I have to write this in a scientific notation, it is 2.1 multiplied by 10 to the power of something. This number, the given number is 0.021. It is less than 1. The number that we just came up with, it is 2.1, of course larger than 1, right? Larger than what we had. If this number is larger than what is the given number, of course we're gonna write negative sign. How many negative sign? We are moving to 2 places, so it should be -2. Is that clear? Better?
Yeah.
Yes, Professor.
Yeah.
Yes.
All right. Okay, wonderful. Or if you just want to remember the way it is, like, you know, if you move the left, it become 10 to the positive. If you move it on the right, it become 10 to negative. You can definitely remember it that way. It is not incorrect. It just, I don't prefer to remember it that way. All right. But you can do as you like. So we did talk about this. So let's talk about the measurement and unit. So before we talk about this, anybody has any question regarding the scientific notation and decimal notation?
No.
No.
Okay, wonderful, great. So now we are going to talk about different measurement that you guys are going to learn in your SCC 110 class or SCC 201 class. Both class has the same measurement, and you gotta be familiar with different units, which is almost same as well. So keep in mind, we are going to talk about this measurement quite often in these courses. The first measurement we're going to talk about is volume. All right, so what is the volume? How do we measure the volume, right? How do we measure the volume? That talks about unit. We are going to talk about length, or we can say it's a distance. We are going to talk about mass, the weight, right? We are going to talk about the temperature of the substance, compound, liquid, all right? And we are going to talk about time, different unit of the time. So keep in mind this 5 measurement we are going to talk about quite often. There's also one more measurement that we are going to talk quite often, which is energy. All right, so these are the 6 measurement. We are going to learn a lot more about this. We're gonna use it again and again throughout these courses. All right. For this, what unit you should remember? All right, so there are unit that you need to remember, and there is a symbol that you must remember. All right, so the unit, I think everybody are kind of familiar with this unit. So volume, if you talk about the volume, how do we measure the volume? I think everybody know that we talk about liter, we sometimes talk about milliliter, sometimes we talk about gallons. If we talk about soda can, we talk about ounce, right? So these are the common unit which we are going to refer to when we talk about volume. In terms of length, what we're going to talk about, length, we generally know we use meter to measure the distance. If you follow football, you must know yard, right? That's of course right. When you go for a run, bike, if you drive car, you know its distance has been measured in miles. If you are from Asia or Europe, you may know that you measure the distance in kilometer. Of course, there is an inch, right? Also, there is a feet. All right, so these are the common unit we use. For the mass, again, gram is the most common one, pound is a common one, right? That's what we use to measure like 1 pound chicken or something like that. Kilogram, again, this is the unit which mostly used in Europe and Asia. So we are familiar with this unit. Temperature. So in temperature, I think most of you guys are familiar with two unit. The first unit is degree Celsius, and the second unit which we use in US is degree Fahrenheit. But you may not have heard about the third unit, which is Kelvin. All right, so this is very important unit you gotta remember. There are a couple chapter which is a chapter on, I think it's a chapter 9 and chapter 7, I think it's for different course. The chapter name is gases. So when you talk about gases, you always have to use the temperature in Kelvin. All right, so this is very important unit you got to remember for this course. Also, one of the most important point I want you to remember is when we talk about Celsius, we say it's a degree Celsius. Symbol is like, degree sign with Celsius, degree Fahrenheit. But remember, we never call Kelvin as a degree Kelvin. All right, so please remember that it is not degree Kelvin, it is simple Kelvin, and the symbol is capital K. All right, with the time I don't have to mention it, I think everybody know that we measure the time in different units, second, minute, and hour. All right, I do want you to be familiar with the kind of symbols we're gonna use, like pound. I think everybody know that is LB, but if you are not familiar with this, make sure you know this symbol. Right, LB stand for pound, MI stand for miles, IN stand for inch, and something like that. For energy, we do use two different units for energy. We are going to talk about that a little bit in today's workshop, but let me just talk about that. Calorie. All right, that is a unit which we measure energy in. That is called calorie. The symbol is CAL, and the other unit is joule. All right, and the symbol is capital J. So make sure you are familiar with this unit. All right, sounds good.
Yes.
All right, so what I'm gonna do, I'm just gonna give you like 1 minute to kind of review this. Try to remember as many unit as you can, right? Of course, you don't have to remember all of this right now. Try to just kind of, try to remember this, keep it in your mind. I'm gonna give you 1 minute to process, and then we can move on. All right, guys. Yeah, okay to move on. Yeah.
Yes.
Yes.
As professor.
Okay, great, wonderful. So again, I have just kind of listed out all the measurement and units which I have already shared with you, right? Again, as I told you, I did not include the measurement, that is energy, in your handout that I shared with you yesterday. So please add this unit in your printout if you have right now. If you do not have it, just take the picture of this and you can add it later on. So this is something you gotta remember, and like we're gonna use it quite often. In terms of the time, I think everybody know what is the relation between the two units. So what we're trying to do here is, this is called equality factor, right? This is called, or we can say, conversion factor. What does it mean? It means knowing this uh, equations, knowing this relation between two different unit, we can convert one unit into another one. All right, that's why we can call it equality factor, or we can call it as a conversion factor. So there are a couple of them you need to remember. There are a few of them which you kind of already know, like 1 hour is equal to 60 minutes. Everybody know that. 1 minute is equal to 60 seconds. I believe everybody know that too. But there are a couple of them which you need to remember for this course. I believe this time is going to be like online course, so you don't have to remember everything, but it is very, very important to remember as you're going to move on. And let's say if you're taking any entrance exam for nursing or any other courses, right? For those, there are a couple of conversion factor you should be aware of, right? Not all of this, but there are a couple of them which you should remember. The one that you should remember is, and most frequently used, so I would suggest you can remember this, the one that I'm marking right now. All right, so these are the most commonly used unit for this course. It doesn't mean that you don't have to remember other one. You should remember the other one as well, as many as you can. But again, for this course, it is going to be online exam. As long as you can keep this conversion factor handy, you can definitely, can solve the problem. But remembering this stuff is going to save your time during the exam. You don't have to look for the pages that where did you write your conversion factors and stuff like that. So there are some conversion factor which you should remember, which I just marked as red sign, right? So right here.
Professor?
Yes, go ahead.
I see under energy there's cal capitalized and then there's lowercase. Is it the same thing, or why is it capitalized? Does it mean anything?
Yeah, so I'm going to talk about that in a minute. All right, we're going to talk about that. So remember this, right? The unit for the time, length or distance, mass, and energy. These are the factors, and I would say like these are the conversion factor which you should remember. Also in energy, as you just asked me, this is the conversion factor between the two unit of the energy. You remember the unit for energy we just talked about earlier? It is calorie. The symbol is Cal, and the joule symbol is capital J. The relation between those two units is 1 calorie is equal to 4.184 joule. Okay, this is something which you remember. Most of the time, it depending on your instructor, sometimes they like to just give it to you for the exam purpose, so you don't even have to remember. But it is just my preference. If you can remember a few numbers, it would be nice. If you cannot, you better ask your instructor, and he or she can guide you through it. The second conversion that we have here, it is very, very important. So I don't want you to waste your time right now, but you can do it anytime you like. If you take any snack wrapper out, like, or any food item, if you read the nutritional fact on that label, you will see the energy that you are getting from that food is generally written as capital CAL. Why? Because in the United States, we use capital CAL, which is capital calorie, to measure the energy we get from each food. So you can check out any wrapper you want. You will always see capital CAL. It means it says how much energy you are going to get if you eat it or drink it. All right.
Professor?
Yes, go ahead.
It is basically the kilocalorie, right?
Yes, that's what I'm going to say. Yeah. So what is that mean? The calorie, that calorie is not the one that we just talk about, small calorie. So that is a difference. When you talk about a capital CAL, right, with the capital C, that is equal to 1000 of the small CAL. So this is very, very important relation that you should be familiar with. It is easy to remember, not that hard. You can definitely see the capital C is larger, right? How much larger? It's like 1000 times larger of small c, right? That's how you can remember. We are, all right? Do you understand this, everybody?
Yes.
Yes, Professor.
Okay.
Yes, Professor.
Wonderful, wonderful. So this is something you got to remember. Of course, if you are my student, I will definitely like to ask this kind of question in the exam 2-point conversion factor, maybe 4-point multiple choice question, of course it is going to be there. So remember, capital cal is equal to 1000 of small calorie, right? In the other word, we haven't talked about the prefix yet. We are going to talk about the prefix on the next slide, but let me just point that out right now. You can rewrite this in a different way as well. So 1 capital cal, you can also call it as 1 kilocalorie. All right, I think you may know this. Let's say if I'm gonna call this like 1000 gram is equal to how many grams, or sorry, how many kilograms?
1.
1.
1.
1.
That's right, that's great, right? As you know, what is this? Kilo. Kilo is called prefix. All right, we can use this kind of prefix in front of any unit we want, right? Let's say in the terms of meter, if we put kilo in front of it, it looks like a kilometer, right? If we have ml, like milliliter, right? We have liter. If we use milli, then it's called milliliter. It is prefix. We are going to talk about that prefix in the next slide, but I just want you to remember, if we use kilo as a prefix, right, what does it mean? It means thousands of that particular unit we are talking about. If we are talking about gram, then it's 1000 gram. If we're talking about kiloliter, then it many, this many thousand liter.
Liters.
We use, yes, question. Okay. All right, so whichever unit we are talking about, if we use prefix kilo, it means it is 1000. The same way we can apply the same concept in the calorie. If we have 1000 calorie, instead of writing 1000, we can just say 1 kilocalorie. So this is another conversion you can remember, which is not different, right? 1 capital CAL is equal to 1 kilocalorie, small cal, right? So it is just different way to represent 1000 calorie. You can write as a 1 kilocalorie. All right, do you understand this part?
Yes, sir.
Yes.
Yes.
Do we have to write kcal or can we write kilocal?
It depends on what kind of question has been asked, but you should remember this too. Okay, so let's say if I'm going to ask you to convert this capital calorie into this small calorie, then you probably need to be familiar with this equation factor. If I'm going to ask you to convert 1 capital calorie into kilo, some like couple of capital calorie into kilocalorie, then you should be using this equation factor. We are going to talk about that in a coming slides. All right, so again, what I'm going to do, I'm going to give you 1 minute to process this, right? Try to kind of, put it in your mind that, okay, 1 kilogram is equal to 2.2 pound, right? Try to put it in your mind, kind of revise it couple of times before we move on. All right, I'm going to give you 1 minute to process and then we're going to move on.
So the capital calorie is the base unit for calories.
Can you repeat?
So the capital calorie is the base unit for calories.
No, actually the small calorie is the base unit, but in terms of the food that we are eating in the United States, yes, this capital calorie is the base unit. But for the course, most of the time we are using small calorie, except when we are talking about the nutritional fact. And in that case, we are talking about capital calorie.
Okay.
Okay. So again, I'm going to give you 1 minute to process this and then you're going to move on.
Professor, since this is being recorded, where would we find the recording afterwards?
Once it is available, once the recording is available, I'm going to send you guys email with the link. So you guys can access this anytime you want.
Okay, awesome.
All right.
Thank you, Professor.
No problem. All right, so let's move on. All right, so I think I'm just going to kind of start slow and build up on that. All right, so let me just ask you a simple question, which I believe everybody can solve this on your own. What I'm going to do later on, I'm just going to show you the technique, right? And let's see how we can solve this kind of problem. So for example, let's say if I'm going to ask you 1.7 h means hour is equal to how many minutes? So I can give you like 1 minute to find out the answer. All right, so you can take 1 minute to find out the answer and let me know the answer. Okay,
130 minutes.
One,
Yeah.
102 minutes.
okay, I'm gonna give you 1 minute again for everyone to process, and then we're gonna discuss that. All right, so I think it, yes, if you get 1 or 2 maybe it should be right, but we're gonna find out. All right, so I hope everybody was able to solve this.
You wanted us to
Yeah.
use the conversion thing, right? Where we put the hour on the bottom so it cancels out with the hour on that thing.
Yes, so that's the technique which I'm gonna show you. Like, of course, this is easy number, and I think probably you can just solve it in your head, or you can do the simple math in your calculator. But what I'm gonna do, I'm gonna show you the technique which I think you should follow for this course to be able to convert all the different unit into the unit that you want. So I'm gonna show you that. Yes. All right, so everybody, you already try that and you already get the answer. Yes,
Yeah.
everyone.
Yeah.
Yeah. Okay, great. So what you did, it up to you, right? It's a math. There are many ways to solve the problem. The way I want you to think about is, right, when you have something like this, what we're going to do first, we are going to talk about what are the known conversion, right? The known conversion that we just talked about in a earlier slide. What are the known conversion? So everybody know 1 hour is equal to 60 minutes. So this is called known conversion, right? Or we can call equality factor. So when you know this, when you know the equality factor or relation between the two units, you can simply do the math. For that, this apply to any unit conversion problem. So keep in mind, this can be applied to anything you see in this course. First thing you should do is always write down what is given to you. So 1.7 hour is given to you. So we are going to write down 1.7 hour. All right. Then we're going to convert this conversion factor in such a way that we can cancel out hour, because we do not want our unit in hour, right? So we're gonna put hour in the denominator. All right, and because we want our final answer in minute, we are going to put minute on top. So far so good, everybody's following me? The reason why we did that, because we want to cancel out the unit hour, right? And other reason is because we want our final answer in minute, because that is the question. We want to find out how many minutes. So we're gonna put minutes on the top. Once you do this, all you gotta do is look at the equality factor or conversion factor and plug in the correct number. Hour, what number we have here? 1. So I just gonna say 1. Minutes, what number do we have in front of minutes? 60. So 60. So hour and hour, the unit cancels out. Now you can just simply do the math, which is 1.7 times 60 divided by 1. Of course, it doesn't matter. And whatever answer you get, that is your answer in minutes. That's right. Is that the correct answer? 1 or 2? Is that the right answer?
Yes.
Yeah. Yes, Professor.
Yeah.
Yes, sir.
Okay. So the purpose of solving this problem is to show you the technique. It doesn't mean that you have to follow the method. You can follow any method you like, But if you follow this method, it's going to be very, very helpful throughout this course. All right, because by following this method, you can solve any problem of any unit conversion. All right, so anybody's any question with this problem? Like, do you understand the technique, what I intend to explain you?
Yes.
Yes, sir.
Everyone?
Yeah.
Yeah.
All right, great, great, wonderful. All right, so let's move on to the similar question, right? In which I just asked you the same, I gave you the same number, 1.7 hour, but now I'm asking you in second, how many seconds? So again, I'm gonna give you like maybe like 2 minutes this time to process this. All right, and after 2 minutes, you can share your answer and we are going to work on this. Okay, so you have 2 minutes to solve this problem. Again, remember, this is easier problem, right? We are just going to build up on this. Okay, so I think is a good enough time. Do you guys get the answer?
Yes, Professor.
Yes, most of you guys tried, yeah.
Yeah.
Yeah. It's
Just
6,120 seconds.
okay, great. Just so you guys know, because I'm kind of sharing my screen, it is very difficult for me to track the chat option, right? The chat, if you're putting anything in the chat, it would be hard for me to see right now. All right, so I'm not looking at it. So in case if you have any question, after the session is over at after 4 p.m., you can definitely ask any question that I may not have answered. All right, so I just saw like, there was like a 76 chat messages, which I did not pay attention to. But if you have any question, if I did not answer yet, you can definitely kind of, put it out there. Okay. All right, so I think everybody know how to solve the problem, but again, I'm just going to show you the technique. The idea here is to understand the technique. First thing to do, always write down what is given to you, right? Now, some of you may know 1 hour, the relation between 1 hour and the second, right? If you know that relation, it's great, right? If you do not know that, and if you just want to keep it simple, right, let's just keep it simple for now. 1 hour is equal to 60 minutes, we know that, but we don't want our answer in minute, we want our answer in second. So we need to use another conversion factor, which is 1 minute is equal to 60 seconds. All right, so basically it is a similar problem in which we just have one extra step. So first of all, we are going to use this conversion factor a, right? What we're going to do, we are going to do the same thing, because we do not want our answer in hours, so we're going to get rid of hour by putting it in a denominator, and the relation that we know is on going to be minute, we can put it on the top. Of course, we know the number in front of hour in this equality factor is 1. Number in front of minute in this equality factor is 60. If we do the math, of course, we know from the last problem that we just solved, it is going to be 102 minutes. Once we have this answer, right, is that the answer we want? No, actually not, right? We want this unit to be converted into second now. So what we can do, we can just continue with this number now, 1 or 2 minutes, and just redo the step that we just did above, right? What we just did here, right? But this time we're going to use another conversion factor in which we are going to put minutes in the denominator. Why? Because we want to cancel out the unit. We do not want that unit. And we want our final answer in seconds, so we can put seconds on the top. That is another reason. Now, what is the number in front of second? It is 60. So we're going to put 60 in front of minute. What is the number? 1. By doing that, we can see we cancel out the unit minute and minute. The only unit we are left with is second. If you do the math, 1 or 2, right, multiply by 60. So it is going to be 6120 seconds. Are you guys following me?
Yes.
Yeah.
Yeah.
Yeah,
Yes.
Professor.
All right, again, this is really easy problem, right? Everybody know how to do this, but we are building up on this to understand how we can do or how we can apply this concept for the unit conversion that we need to know for this course. All right, anybody's any question from this now? Anybody?
I have a question about the abbreviation for seconds. Is it S or SEC?
It's SEC. It should be
On
SEC.
the previous slide, you abbreviated it as S, I think. Does it matter?
Then it could be just my mistake. All right, then it could be just S. All right, I generally like to write as a second, right? I generally prefer to use second itself, but if I made a mistake, yes, it could be my mistake. It could be S.
Professor?
Yes, go ahead.
Now, does this equate to all the other forms of conversions? Like, is it always going to be over 1?
You mean this, right?
Yes. But
Yes,
it's
it
not.
depends on what we need to find out, right? It's not over 1, but we can always focus on the unit. Whatever unit we want to cancel out, we has to put it in a denominator, and the unit we want our answer in, we have to put it on the top. Let's say if we have another conversion factor, let's say like if I'm going to ask you in opposite direction, let's say 102 minutes, right? Let's say seconds equal to how many minutes, right? Let's say if I'm going to ask you this question, then what you're going to do, of course, write down what is given to you. So 102 seconds, which is given to you, right? Multiply by what you're going to find out, because you do not want your answer in second and you want to cancel out the unit second. You're going to put second in the denominator and you're going to put minute on the top. Why? Because you want your final answer in minute. In this example, what you're going to do, you in front of second, what number you have? 60. So 60 should be in front of second. For minute you have 1, so it should be like this. So now it's kind of opposite. You see that?
Yes.
All right, so it is not necessarily has to be 1 in the denominator. It could be any number depending on what equality factors you have and what actually you need to find out.
So as long as it's just 1 unit of what we're using. So like 60 seconds equals that 1 unit of seconds or of minutes.
Yes, that's right. Get it? Is that clear to everybody?
Yes, thank you.
Yeah.
Yes, Professor.
Okay, great. All right, so based on what we just learned, I want you to try this on your own, and then we are going to solve this. At the same time, I have given you all the conversion factor that you need to know to be able to solve this problem. All right, eventually I would suggest you to remember as much as you can, but at least for now, because we just started to learn, right, I have given you all the conversion factor that you may need to use to solve the problem. In here, the question says 2.54 lb equals to how many grams? All right, so you have to convert pounds lb into the grams. The conversion factor that you need is right here. Again, this is kind of a little different than the one that we did earlier, right? The time and second, everybody know that. This time is a bit different. I'm gonna give you 3 minutes to kind of attempt this and solve this. Okay, give your best attempt. and then we're going to discuss. You have 3 minutes to solve this. If you have any question, you can definitely ask me, okay? Okay, guys, I'm gonna give you 1 more minute and then we're gonna work on this, okay?
Professor, I have a question.
Yes, go ahead.
So just like this problem, if instead it would be however much grams and they would want you to do kilograms, it would be the same way?
If the value is given in a grams and question asks you to find out in kilograms,
Yes, it's the same way.
yeah, in that case you just need to use one conversion, right? Grams to kilograms, right? We are going to talk about that. Like we haven't talked about the prefix, but in that case, right, grams to kilograms or maybe kilograms to gram, the conversion we're going to use is like 1000 gram is equal to 1 kilogram. So it would be like a different conversion, right? Okay. Do you get it?
Yes, and it would be the same thing for pounds to kilograms. It would just jump like that.
Yeah, it would be just the first one then, right? If it's pound to kilogram, you just need to use the first one.
Thank you.
Yeah. So again, I think everybody must have tried and everybody should know the answer by now. So remember, right, these are the conversion factor. It doesn't mean that you have to use all of this. I give you 2 conversion factors just to see what you guys understand, and maybe it looks like everybody got it right. There is no need to use this conversion factor to be able to solve this problem. All right, did you get that?
Yes.
Right? He did not use this conversion factor, right?
Only the second one.
Only the second one. That's right. Very good. So that was the intention. Okay. So that's the idea here. All you gotta know is you should know which conversion factor to use. As long as you know that, that's all it is about, right? Again, to solve this problem, as I told you earlier as well, first thing to do is write down what is given to us. Then you are going to find out the conversion factor that you need to solve this problem. And here we are only going to need the second conversion, in which there is a relation between pound and gram, which has been given to you. In this example, because the pound is on the top and we want to cancel it out, so we're going to put pound in a denominator. And because we want our final answer in gram, we can put gram on the top. All right, now let's just find out what number we have in front of gram, which is 454. What number do we have in front of pound? 1. So 1 is simple math, right? Pound cancels out, just multiplication. Do the math and you get the right answer. Do you understand that?
Yes.
Yes.
All right, so again, it's a math. You can solve it any way you like. This is the way I want you to think about. If you can process this way, it would be kind of very helpful to you. All right, again, you can do it any way you like. Instead of this, let me just change the number just to make sure that you understand this. Let's say if I'm gonna give you a number in okay, all right, it will be okay. Let's say this. Let's just keep it simple. I just want to see that you understand this. All right, instead of pound, let's just assume I'm going to give you the quantity in kilograms. All right, I think I already give you the conversion factor that you need to use. In this screen right now, you have like 3 conversion factor, A, B, and C. So you can use any of this to solve this. Okay, for this, I'm going to give you kind of minute and a half because we just work on this similar problem. So I think you should be able to solve this. So you have 1 minute and like 1 minute and 30 seconds or something to be able to solve this. If there's anything you do not understand, feel free to ask me. Okay, this is not like a lecture. All right, I am here to help you guys. So if there is any part you do not understand, feel free to reach out to me and ask me a question. Okay, all of you guys have tried this already? Yeah.
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 Yeah, okay, great. So this is going to be very simple. The kilogram has been given to you and gram is something you have to find out. If you look at all these 3 conversion, you should be able to figure it out that yes, you are going to need the conversion factor, which is C in this case, to be able to solve this. All right, again, the technique is same, right? Just write down whatever is given to you with the unit. Now the unit which has been given to you, of course you do not want that because this is unit conversion, so you want to cancel it out. To be able to cancel it out, you have to put it in a denominator so you can cancel it out. And you want your final answer in grams, so gram must be in the top. Now once you put it down in this fashion, you just need to find out what number you have in the conversion factor. So with 1000 grams should be in top, kilogram, that is number 1, is simply multiplying with 1000. It should be 2540 gram. All right, everybody got it?
No.
Yes. Yes.
Yeah.
Yes, Professor.
Okay. No?
No.
What part is
So
it?
what I did, because I didn't even see that there, I changed it from kilograms to pounds and then to grams.
That should not be a problem as well. You're still supposed to get the same number.
I got 2536.9 if I
Okay.
did.
Yeah, that's fair. That's fair. Right? Yeah, 2536, right? Which is pretty close to this number. It just because you use this conversion factor and it has like a different value here. So you get a little close number, not the exact number, but it should be fine as well.
Okay.
Okay, but yeah, just keep in mind, right? Of course, we are learning right now. This is the most commonly used conversion factor. We're gonna like kind of we're gonna talk about the prefix in I think in the next slide also, and you will know that these are the prefix which we use quite often. All right, so we don't have to take like a long path like this. Okay, but if you have done it this way, it should be fine as well. But just keep in mind for the exam purpose, probably when you have a same unit like grams and grams, right? The unit is same. The only difference what we have here is a prefix is kilo. So when we have the prefix, we are going to stick to the table that we're going to talk about in a next slide. We just use that as a conversion factor. Okay. All right. Anybody have any other questions before we move on?
No, sir.
Okay, wonderful. Great, great. All right, so this is the prefix that I want you to remember, and it is something we have to remember. All right, it is not just I'm asking you to do it. I think it is very, very important for you to remember. I'm going to try to help you to remember this all the prefix, but first of all, let's talk about what is prefix, right? So prefix is something that we can use in front of any unit, like just the way we use, right? Grams, we can use like kilograms. So kilo is considered as prefix, right? If we have meter, we can use cm, which is centimeter. So again, centi is the prefix. All right, so that way we have different prefixes. There are few prefix that we should remember. There are few prefix that we do not use this like that much. If you know it, it's good. If you don't know it, it's fine, at least for this course. So in this, these are the last two which you do not like, not necessarily has to remember. The picometer and pico and femto. All right, I should not have done that. Okay, let me just rewrite that in case if you want to kind of want to remember this. Small p and femto, small f. All right, so these are the two which we do not use that frequently, like I would say like rarely use this for this course, but these are the one we used very, very often. It's a deci, centi, milli, micro, and nano. So these are the five prefix which I want you to remember. Now, what are these five prefixes are? So whenever we use this prefix, like deci, the symbol is small d, centi, the symbol is small c, milli, the symbol is small m, micro, the symbol is like mu, or sometimes we use mc. All right, which you can see here. All right, sometimes actually we use micro like mu, or we can use mc. And another symbol is nano, which is small n. As you can see, all these symbols are smaller later. This is one way to remember that all this prefix is actually smaller than the given unit. So whenever we talk about this, let's say 1 meter. All right, okay, let me start with 1 decimeter. 1 dm, d means deci, m means meter. If there is 1 decimeter is equal to how many meter? All right, if you need to remember this relation, what that relation is going to be, you should know deci is small later, right? D is small later. It means you're going to start with negative sign, negative 1. So 1 decimeter is equal to negative 10 to the power of negative 1 meter. Again, you can apply this prefix to any unit you want. You can also apply this to liter, right? And the value is going to be the same, 10 to minus 1 liter. So just do not focus on the unit, what we are talking about, liter, meter, gram, it doesn't matter. We are trying to focus on the prefix and what its value are. All right, so deci, it is 10 to minus 1. If you talk about centimeter, cm, right, which we which you may have heard about quite often, right, is equal to 10 to the power of minus 2. So I think at this moment is simple as long as you can remember this in order. D, deci, then is centi, starting with minus 1 and minus 2. So this is not that hard, right? Followed by millimeter, small m, right? Small m stand for milli, the second m stand for meter. That value is going to be minus 3. So you're just going by 1, right? Increment of 1, minus 2, minus 3, right? DCM, minus 1, minus 2, minus 3. So far so good, everybody?
Yes, sir.
Yes, Professor.
Yeah, great, wonderful. And now starting from this point onwards, we are going to we're going to increment in order of 3. So instead of 1 2 3 4, now we're gonna do it's 6. So 1 micro, so I'm gonna say mc m, or I can say micro like mu or u, right? That is going to be minus 6. So now everything what we're going to talk about from this point is going to be increment of 3. So micro, it will be 10 to the minus 6. And nano, n is nano, m is meter, again 10 to power of minus 9. All right, so these are the 5 prefix you must remember for this course, no matter if it's 110 or if it's 201. We also have 3 more, I would say 3 or 4 more prefixes that you have to remember, which is the next slide. But these are the prefix which represent a smaller value, right? Why? You can remember this way. So small letter, centimeter, right? C, small d, small m. It means it represent a smaller value. Also, you can remember it this way. When you pronounce it, it end with I or O. Right? When you pronounce it, deci, centi, milli, micro, nano, either it end with I or it will end with O. In that case, you can also remember that way that this is going to be represent a smaller value. All right. Again, you don't have to stick to any one unit. I'm just going to give you one more example here. 1 milli G is equal to how many G, right? What is the answer? The gram and gram is same. The prefix milli stands for 10 to power of minus 3. It means even if you're talking about grams or liter or meter, doesn't matter. The prefix value is always going to be the same. 1 milligram is equal to 10 to the power of minus 3 grams. You guys following me?
Yes, sir.
Yes.
Yeah.
All right, so as you can see, we have used different unit in here: liter, meter, second, grams, right? You can use different unit, doesn't matter. We are trying to focus on the prefixes. All right, again, I'm going to give you kind of 2 minutes to process through, right? Try to remember as much as you can, and then we're going to move on and going to talk about the other prefix that we should remember. All right, deci, centi, milli, micro, nano, right? Minus 1, minus 2, minus 3, minus 6, and minus 9. Again, I did not mention that, but if you want to remember pico and femto, it is again increment of 3, so it should be minus 12 and minus 15. All right, we don't use that much in this course, but in case if you want to remember, you can definitely do that. All right, guys. So can we move on? Yes.
Yes, Professor.
Yeah.
Yes.
Okay, great. All right. Now we are going to talk about the other prefix which have higher value. All right. What you mean by higher value? It means it should be 10 to the positive power. All right. If we, when I told you to remember it like I or O, which has a smaller value, there is only one exception, which is kilo, which end with O. Otherwise, all of these end with A. Right. Anything that when you pronounce it, if it end with A, the any prefixes and with A, that is going to be a positive number. All right, you can remember it that way as well. Or if you just look at it in the symbol, the capital, like sorry, kilo is the only one letter which has a smaller letter like small k. Everything else, mega, capital M, giga, capital G, tera, capital T. Right, we don't use peta that often in this course, so you don't have to worry about this. Okay, so this is only one exception, kilo, which end with O and it had a smaller letter, but this is the one we use quite often in our routine life as well. So you know, kilo is a higher number than whatever unit you are talking about. Anything other than that, like a mega, giga, and tera, you can see it's a capital symbol. That's the one way to identify. Also, when you pronounce it, you end with A, right? So that is going to be a larger number. Now, what is going to be the value for this? This is pretty easy, right? It's not a magic at all. It is simple increment of 3. So if I'm going to call this 1 kg is equal to how many gram, right? Kilo means 10 to the power of 3. If I'm going to call mega, capital M, right? How many gram is going to be? Mega is going to be 6. Then it's going to be giga, capital G. How many gram is going to be? 9. So it's like increment of 3, 3, 6, 9. These are the kind of 3 you have to remember. Of course, you can remember the tera, T, G, 10 to the power of 12 gram. All right. Now let me just kind of give you a more easier kind of unit that you can remember this one. So if you remember, like you might have like a old cell phone, you used to have a cell phone with not like smartphone. In that case, when you take the picture or save any file, it used to be KB, if you remember. Have you seen this unit anywhere in your phone, right?
Yes.
No.
You have? No?
I have, yes.
Yes, yes.
Not
Yes, kilobytes.
Kilobytes. So if you haven't, it's fine. You can definitely check out right now. Like if you take any picture with your, even with a smartphone, and if the resolution is not that great, it may be saved in a KB. What is K? K means again it's kilo, but B stands for bytes. So bytes is a unit of the storage, the memory that you occupy, right? In your cell phone, the memory it occupies, the unit is called bytes. So that's what it stands for, KB. It used to be KB. Now with the smartphone, because the resolution is great, you are taking a nice picture. It is in MB. MB means megabyte, right? Capital M, of course, my bad. Capital MB, right? If you want to try this out, you can definitely take the picture and look at the detail. You will see the memory that you're going to use is going to be MB. It means the storage is megabyte. Mega means 10 to the power of 6. This is kilo, means 10 to the power of 3. All right. Of course, you may have a laptop by this time. If you check out what is the storage in your laptop, you must know it is GB, or also like you can check the RAM, or if you have, yep, right. If you have like iPhone or any other phone, you may know the storage is 128 GB, 54 or 28 GB, whatever it is, right? 256 GB if you really want to have like a huge data storage in your phone, right? So it's GB. GB is again 10 to the power of 9. And if you are a fan of technology, if you like to store your data in your external hard drive, you may know the external hard drive is now 1 TB, right? 1 TB, 2 TB, 3 TB. It means terabyte, 10 to the power of 12. So starting with the small c, like small space, which is kilobyte, then is megabytes, gigabytes, and terabytes. So this is the easier way to kind of maybe remember if you know the technology and if you have seen this unit bytes. All right, if you haven't, again, it's still easy to remember. Is increment of 3, 3, 6, 9, and 12, starting with kilo, mega, giga, and tera. All right, sounds good. Do you guys understand this part?
Yeah.
Yes.
Yes.
Yep.
Yes.
Sure. Go ahead. Question?
But I knew that the bytes are symbolized as capital B.
Yes, it is B. Yes, it's capital B. It's my bad.
Yeah.
Yeah.
If it's a smaller B, then it's called bit, I think, right?
Yeah, that's different. Yes, it bits is different. Yeah. Thank you for correcting that. All right. So yes, that's right. And what I'm gonna do, I'm gonna give you 1 minute again to process this, to try to remember as much as you can. Right? You don't have to remember everything today. Right? You have entire semester to kind of understand this. But as you are having this workshop, I want you to remember as much as you can. So I'm gonna give you 1 minute to process this, and then we're gonna move on. All right, guys. So moving on. All right. We just going to solve how many? 1, 2. Okay. We are going to solve just one problem